Good day and welcome to the Bearded AI Guide. Today we're going to be talking about building autonomous assistants or agents, and this is an excerpt from my book AI Agents in Action, Chapter 6. So autonomous agents and assistants can be controlled by a number of things. It can be controlled by agent workflows, which is really popular in a tool called LangChain. There's other tools and software products out there that try to use various workflow technologies and things like that. What I've done here is using behavior trees, which are very popular in gaming and robotics. If you've played any game with a non-player character, you've probably encountered behavior trees before. As I said, advanced robotic systems also use behavior trees, and it's sort of a designated thing. They've been around for quite a long time. They work well because they provide a level of control. Since they've been integrated in robotics for so long, they have a number of safeguards and systems that allow you to control the limitations of the agent or robot, if you will. And these work well, obviously, for applications of AI agents using large language models. So what I really want to get into now is to talk about what our behavior tree. What you see in front of you is a simple diagram of a behavior tree, a very simple behavior tree. And at the top of the diagram, we have the root node. And in this case, it's called a selector. It's denoted by a question mark. The question mark or the selector node essentially means that it's going to go through and select whichever node succeeds underneath it, going from left to right. So it will try and go through the first node on its left side, and if that node succeeds, it will come back and complete itself. If the node fails, it moves on to the next node. Versus a sequence node. The sequence node is shown by the arrow, and the arrow denotes sequence of activities that will happen underneath that node itself. So you can see in our example here, we have a top node of the selector, and the first node underneath it is a sequence node. And that sequence node is going to activate from left to right a condition node. Condition nodes are these oval-shaped nodes. If the AI or agent or robot has an apple, it will move to the next sequence, which would be eat apple. If it doesn't have an apple, it's going to fail. That failure is going to come back up to the sequence node, and the sequence node is going to reply back to the selector. The selector, in effect, is going to say, okay, you didn't work out. I'm going to try the next node to see if that's going to work. So we'll try the next node, which is, again, another sequence node. This time, the first node of the sequence is a condition that says has pair. And if that condition succeeds, then it obviously will eat pair. There is no other positions from here that can continue, but this is really a very basic behavior tree. You can make these as far more complicated as you like, or even a little more simpler. The power in here is that you can break off and combine other sort of behavior trees. You can join subsets of behavior trees, and behavior trees can almost act like components, if you will. So in the case of our autonomous agent we're going to look at today in our demonstration, we're going to review the blogging agent I use to write or have written Medium blog. What this blogging agent does is it goes to YouTube, pulls down a bunch of YouTube transcripts that match a certain search term, summarizes all those transcripts, saves all that summarization, and then another agent comes along, writes the blog based on all those summarizations. It will pick the topic that seems to match its best criteria, and as it's writing the blog, it will also include images, so it will generate images using DALL-E 3, and then it'll write a Word document. I wanted to use a Word document because then I have a document that I can use as an archive, and I can compare and do various things. It also allows me to include images and other sort of special content. And then what I'll do typically is just take that blog written as a Word document and copy and paste it into Medium. This just provides me a lot more editorial control. And at the end of this, there's a post cleanup operation which will delete files. So in this particular case, we have at the root a sequence node. Remember, the sequence node is going to operate from left to right, and it's going to try and run each of these nodes. Underneath the sequence node is a search selector node. We define this with a selector node because we might, in a future instance, want to provide different methods of search. So if one method failed, say there wasn't any videos on YouTube, we might search another alternate channel, a news channel, or Reddit or something like that, for instance. When that content is collected and successful, it will come back and execute the next node in the sequence. If there is no content, though, it effectively just retries and runs the whole search again. If it is successful, it'll go on to the next step of the blog writer, and the blog writer will then write a Word doc, again, creating images, adding paragraphs and headings. And at the end of all of this, we do a post-cleanup operation as a way of just making sure that the state that we started with is the state we end with. And that's often very useful just to make sure that you're not getting extra pieces or parts of documents aren't laying around that shouldn't be. Hello everyone. Today we're going to start with the code. I'm going to be showing you the code for the Agentic Behavior Tree. What we're starting here with is just the imports. You can see PyTrees is the behavior tree package that we're using. It's a package used for the robotic operating system, used for robots, again, used for controlling non-player characters and that type of thing. Top of the behavior tree, we always start with the root. In this particular case, we're using a sequence node as the root. What we're putting underneath that root node is a selector node. The selector node again, acts like an OR, if you will. So doing one task or another task or another task until one task succeeds. In this case, I've decided to use the selector node as the top of the search functions so that we can add more search functions if need be. So if one of those search functions fails, it will just try to move on to the next search function and so forth. In this particular case, though, I'm just using one single search function. The instructions for that search function are here. I won't get into them quite yet, but what I want to go to next is the nodes themselves. The first node you can see here is the search YouTube node, and within that, we're using the assistant of YouTube Researcher and V3. So this is the third iteration of me developing this YouTube Researcher. Instructions are the get search instructions, which are here. We'll go over these instructions and how this works in a little bit, but let's just continue going through the behavior tree nodes themselves. From that node, that completes the selector node, and then from the selector node, it goes back up to the next action, which is the write blog action. The name of that action is the write blog. The assistant name is the medium blogger. And we'll get into what each of these assistants are here in just a second. And the assistant's instructions are all here. So this is adding the write blog action to the root. And then the last and final action is just a little bit of file management. So what each of these actions do is the first action, YouTube Researcher, through these instructions and its own assistant instructions, goes and downloads the transcripts from a bunch of videos from YouTube. So it's using this YouTube transcripts library. It's using a YouTube search function library or tool, if you will, or action, downloading those into a file called YouTube transcript. We're using a file as a way in order to sort of limit the amount of conversation. Conversations are good for extracting emergent behaviors, getting more interesting things happen. But if you want a controlled situation, your best way to do it is to pass your elements from one agent to another in some finite packages. So it could be a string or whatever. In this case, it's a string that's just encased in a file called YouTube transcripts.txt. The next action, so this write blog action, loads up those YouTube transcripts that have been downloaded and summarized and pulled in from the YouTube Researcher. It loads all that stuff up, and then using its instructions here, goes through and writes a educational tutorial, informative, or demonstration content that extracted from those summarizations. It's essentially making the decision of what content to write in the blog and then writing the blog. In both of these agents, they are going through multiple steps. In the search YouTube and the YouTube Researcher, it is first searching for YouTube videos, then downloading the transcript from those videos, summarizing transcripts, and then saving those transcripts. Likewise, the medium blogger is loading the transcripts, taking those summarizations, and making decisions based on its instructions on what type of blog to write. It then decides on that blog, and it goes through and writes the blog. This assistant, the medium blogger, has a whole bunch of instructions on what type of blog it's supposed to write, the format of that, and all that. We'll get into that in a second. It uses its own instructions on how to write and generate the blog. It writes and generates a blog to Word document file, and then ultimately, if I wanted to post the blog, I would just copy and paste from the Word document. The Medium API that normally you might use to automatically post these things is not supported anymore. It's deprecated. for various reasons. This just seems to be more of a safe way, and copying and pasting the blog is only a 10-minute exercise at most. Sure, it can be automated, but this gives me more control, editorial control, and I can see what actually is getting posted. The important thing to realize here is that the blogger is not making up anything. It's taking the content from the YouTube videos, and it should be also highlighting the references for those videos as well. You can see here, it's one of its instructions are to make sure and reference each of the links in the videos or the videos it's using. And then the last cleanup exercise is essentially just deleting the YouTube transcripts file so that when we go through our next iteration, if something happens or breaks and it gets to this step, it's not rewriting the same blog. So effectively, we're always rebuilding the YouTube transcripts file and then passing it on. And then at the end of the operation, we remove it and clean it up. Finally, at the end here, we construct the tree, and then it's just a simple matter of while true. So what this means is that this will continually run forever until we stop it. This could be controlled by it completes a 3-step process, it will stop. In this case, it's just a never-ending run of over and over and over. And I'll typically go through and I might write 5 to 10 blog posts using this, and then just going through and searching and deciding which ones I want to use. All of this is put together through the GPT Assistants Playground, which has a API interface that allows you to communicate through a bunch of the tools that are in the assistants. So really the only thing that you have to do in this particular case when constructing these behavior trees is just run this function, create assistant action, define it in these terms here, and enter your instructions and all that, and you effectively have an easy way of generating a multi-agent system. Okay, here we are in the GPT Assistants Playground, and we're just going to go through and look at each of the assistants that are used in that exercise before we go through and actually run the workflow. As I've said before many times, I've got a whole number of different assistants I've already created that do all sorts of things, from this medium blogger as an example, creating the PowerPoint presentations you see as part of these videos, to the number of things. The sky is the limit for all this stuff, really. The YouTube Researcher V3 is here. You can see it has its own set of instructions, what it needs to do, how it needs to do it. It is essentially about how to summarize and build that transcript file, is what these instructions are, how to search YouTube. And again, its actions are get the search term. So it's getting a search term from a database to apply to what content it's going to pull. That term, I keep it in a database or in a list because I want to make sure it's easily changeable. I can swap search terms out or modify them. And eventually what I'll plan to do is sort of understand what the impact of each of these search terms are. It has a download transcript. So this is a download transcripts API function. Search for new YouTube videos is another API function. And then the saving the file is another action. The medium blogger is another assistant with its own custom set of instructions. And you can see here in this example, it's understanding what persona to use. In this case, we're embodying Ernest Hemingway as sort of how to write the blog, if you will. And then it's given explicit instructions on how to write the content of that blog. And its actions include adding or appending code to Word documents, images, paragraphs, headings. It can create images, and it can create Word doc. So its whole purpose is essentially to create a Word document of the blog that I will then use to post when I want to or need to. I decided not to use any API or anything like that because I wanted to have more control. So now we're back in the code, and we're just going to go ahead and run this. My debugger to file, which is going to allow me to run this. So I'm just going to go ahead and run this now. And I'm just going to run in the debug mode so we can see what's happening. Okay, so what you can see here is it's going through each of the actions. It does an initialize, an update, and then for each action is running on a thread. And then from that thread, you can see each of the actions that the assistant's taking. So what we just seen is a blast there. Let me just scroll back up. It's got the search term. Now it's searching YouTube videos on the search term. And then from there, it's downloading the transcripts. So that's what you're seeing all here is the transcripts from each of the videos. And it's pulling down, I think it's 5 videos it'll go through and pull out from this week for the particular topic. So it's searching by Searching for YouTube videos for a particular topic. YouTube is an excellent source for everything these days, and it's really a good information source for a lot of things. Other content, of course, gets to other social media sites, but YouTube has really become popular for a lot of things. Okay, you can just see it's downloading the transcripts. After every 30 seconds, it's going to ping that. You see that little update there, and you'll see at the end here, all tasks completed successfully, and it's saved the file to YouTube transcripts.txt. Then we'll wait a few seconds here, and the writing blogger, the Medium blogger, will start. Okay, so there it goes. It started. It's loaded the transcript, so there was a summarization. It's getting a timestamp, so it's going to timestamp the file. You can see here it's the video. It's AI video blog is what it's writing. It's going through. In this case, you can see it's discovering some stuff here. Exploring runway. Through each of these things, it's creating the Word document, and it's also creating images. The interesting thing here is sometimes it will go through and encounter errors as it's running the function to create the image. It recovers from that error by itself and then decides the proper way to call the function. Sometimes it'll just give different dimensions for the image that's not supported by DALL-E 3, which is the Create Image API that's being used behind the scenes. But what you can see is it's recovering from that, and then it's appending the image to the Word doc. So we'll just go through here, wait a few seconds, and we'll bring it up and we'll look at the Word doc. You can even see it's adding captions to the images, and it generally creates an image for every section that it's adding to the blog. Now, typically the cost for one of these runs might be $1 or so, and that's because the images, and there's a lot of tokens going through for the writing and just from the summarization docs and then the transcripts and stuff like that. So there's a fair number of tokens that go through this process. That's driving the cost up. If your process or your agent process was using a lot fewer tokens, then it would probably be much cheaper. The big expense here is the number of tokens because it's pulling full YouTube video transcripts and then writing documents and stuff like that and creating images. Generally, though, if you're not using a lot of tokens, the cost will be substantially cheaper for you. Okay, so we can see the write blog completed successfully. What I'm going to do now is just let it finish. You can see that last cleanup step, okay? And you can see the post went through and it deleted the file, and that essentially is one full run. So let's go through and look at the file. Okay, and here's the completed blog post that's intended for Medium. You see it starts with the title and it's added a number of images. The topic here is Runway Gen 3 Alpha. Time of this video was just released and is showing a major impact in video production. Also goes through, it looks like some tutorial stuff on how to get these things, how to maximize video quality, but it's added some images, some really cool images and other video generation stuff. Some really interesting stuff here. Then the future of AI video production and some conclusions. And it looks like a really interesting. The one thing I can see, and I'm just looking through here, is that I think it missed the reference to the video that it pulled most of this information. That I'll have to go back and fix. But overall, you can see it's completed this whole blog with the images and everything. What we just seen is an example of an Agentic Behavior Tree. I call it Agentic because it really is more to do with agent, and it has a lot more characteristics with agent behavior, which is a little different than the applications for robotics and NPCs in game. In an Agentic Behavior Tree, the prompts and instructions act as the actions that the agent takes for each of its steps. But an agent for each step could actually have to complete multiple tasks or a goal. If you've seen the actions video, you can get more understanding of what happens when an agent works through and completes goals, or why we need an agent that can complete goals. In this particular case, in this example, I'm using the Assistants API because, as I've explained before, it provides planning capabilities, which makes it more powerful. If you were to try the same system with just a GPT 4.0 model, for instance, it wouldn't get very far because it would essentially want to iterate through behavior. These agents will work through an entire goal through an action specific node to complete that and pass it on to the next stage. In my book, chapter 6, we talk about a lot more other examples, coding challenge, a social media post, and even how to add different conversational patterns. In this system that we've just demoed, there is no conversation agents. That doesn't mean that can't be the case. There can be conversations among agents that allow it to be more conversational and get those emergent behaviors that we often like to see when we're exploring and doing R&D. If you're just doing a agent system, though, that you want to make sure that it's controlled, it's going to do what you want it to do, then you want to control each step. You want to control what the assistant's doing. You want to control what each activity is happening at each set of goals and the outcome of those goals. And this agentic behavior tree pattern allows you to do all that. Thank you for watching, and please comment and subscribe.